So in terms of the log structure file system, we can see that within the entire log file system, since we understand its great concept, which is to avoid any random write operations, and instead perform sequential write, treating it like a log. In the log structure file system, the free space is managed using fixed size segments. The hard drive is divided into fixed size segments. Write operations are first written into memory, where they are serialized. After serialization, if the cache data in memory exceeds the size of segment, the log file system will write this data into free segment all at once. This means that I use memory buffers and perform sequential serialization. When the serialized data reaches the size of segment, the data is written into a free segment all at once. The benefit of this approach is that it reduces random write and frequent seek operations on the hard drive. This applies to both traditional hard drives and solid-state drives, reducing the frequency of command operations. By writing the data as a block, we reduce the interaction between memory and hard drive. This is also a resource-saving advantage of log structure file system. Additionally, in the log structure file system, how does reading operate? To read records, the log-based database management system, DBMS, scans the log backward and reconstruct the tuples. It needs to scan the log from back to front and build an index, allowing it to jump to the corresponding position in the log. The read records, it needs to reconstruct the tuples. The benefit is that the write speed is fast. However, considering the reading process, read speed is actually very slow. The append-only approach works well because the database doesn't roll back or redo or update the data. It continuously appends. To avoid slow read, we can build an index. The database can build an index to jump to the specific position in the log. And we can periodically compress the log by removing invalid operations. Periodically, we can compress the log to exclude invalid operations. If a tuple is updated, we can store only the inserted tuple. However, everyone knows that compression can lead to write amplification because it involves writing the same data repeatedly. To address this, we need to introduce operations such as garbage collection and other corresponding structures. Earlier, we mentioned that we allow indexing in the log file system. So how is indexing done? It is done like this. Within the segment, the contents of the log file are stored in the data blocks of the same size. For example, in the log file system, we compact segment with expired data blocks, forming new segment and deleting old data from the segment. How do we determine which data expired in log file system? At the beginning of each segment, a summary is created. This summary head stores the address of each data block in the segment. By comparing this address with the IMAP and inode index, if the addresses match, it is valid. If not, block is expired. Expired blocks are marked and compacted into a new segment, freeing up space and forming new segment. Thank you all very much. We hope to continue sailing in the vast sea of domestic database and make progress together. Welcome again. This is CnosDB. You can join our CnosDB Discord channel. And please sign up for the CnosDB Cloud as well. You can join that very easy in the cloud as well. Thank you. See you next time. Bye bye.